Hello. In this tutorial, I will talk about the linear transformations. Linear transformations. A linear transformation is represented by this symbol T, colon Rm to Rn. So if we have some vectors with m components, so with the transformation we can transform those vectors into n components. So such a thing actually normally happens when we multiply two vectors. So therefore multiply two matrices, and then their order of those matrices actually change. So for example, if we have some vectors u and v in Rm, okay, and we can have some scalar R. So for linear transformations, there are two conditions that will be met. That will be that the transformation of u plus v vectors, okay, because both u and v are with m components, so we can add these two vectors. In their transformation will be the sum of their transformation will be equal to the transformation of u, the same transformation of u plus the transformation of v. Okay, so this is one rule for the linear transformation, and the other rule is that transformation of a scalar times some vector will be equal to the that scalar times the transformation of that vector. Okay, so in this case we will call that there is a domain. Okay, there is a domain. So the domain of this transformation will be, in this case, will be Rm. Okay, that means the set of all vectors with m components. And the other one, if after the transformation it goes into Rn, so the codomain, okay, codomain will be Rn. So that means the input will be something like domain, and the output will be like codomain. So if we multiply two matrices and then their order changes from n to n, then we can say them these are the domains and the codomains. And then if we have this vector u, like as before, in Rm, okay, in Rm, then its transformation will be called as the image of u. So when we, for example, if we will transform it, okay, that will be called as the image of u. So these are some of the terms, and all the set of all those images, okay, set of all those images, set of all images vector will be called as the range of T. Okay, it will be called as the range of T. That is represented by range T. Okay, so this is something like a kind of like an abstract theory about that. So let's see some of the examples. Okay, so that the concept will be more clear. So generally we define the transformation as a product of two vectors or matrices. So for example, if we define the linear transformation something like this, AX, so where A is a vector, A is a matrix, and x is some vector. Okay, so tx is equal to ax. So if we have, for example, if this is the relationship which defines the transformation, and if, for example, if we have a is equal to 3 4 0 2 as this matrix, and if we have a matrix like U is equal to 4 minus 1, so what will be the image of U? Image of U. So image of U is nothing but the transformation of U. Okay, transformation of U. So that means in this case, this is the definition of the transformation over here. U will replace X. Okay, so it will be T U, and then it will be Tu will be then equal to A times X, or A times U. Okay, so A is 3 4 0 2. It is this multiplication of these two matrices. So this is 2 by 2 matrix, this is 2 by 2 matrix, and then this is 2 by 1 matrix. So we can multiply it. So 3 times 4 plus 4 times minus 1, and then it will be 0 times 4 plus 2 times minus 1. So what we get is 12 minus 4 is 8, and then 0, and then minus 2, so 8 minus 2. So the image of U will be this vector 8 minus 2. Similarly, if we have in this case, if we, in the part B, if we have A is equal to 1 3 minus 1 0 3 3, and U is equal to 3 minus 2. So then what will be the image of U? So because this is a 3 by 2 matrix, and then this is a 2 by 1 matrix, so it will the multiplication is possible. So its image of U will be, in this case, will be 1 times 3 plus 3 times minus 2, 3 times minus 2, and then minus 1 times 3 into 0 times minus 2. Okay, 3 times 3 plus 3 times minus 3, so 3 times 3 plus 3 times minus 2. So in this case it will be 1 minus 6 is this is 3 minus 6 is minus 3, and then this is minus 3, and that is minus 3. 9 minus 6 is 3. So minus 3 3 minus 3 minus 3 3 is the image of U in this case. As you can see that the meaning of this transformation over here is just the multiplication of these two matrices. Okay, our next question is, okay, our next question is, if we have A as 3 0 minus 1 1 2 3, and V as 4 2. So we have to determine if V is in the range Tx is equal to Ax. So V, if V is in the range of t of x, transformation of x, ax. Okay, so the meaning of this statement is that we need to determine if there is a solution to the linear system ax is equal to v. Okay, if there is a solution to this linear system ax is equal to v. So for this we need to write the augmented matrix, and then we need to determine its echelon form. 1 2 3 4 2. So for making it into the echelon form, what we can do is we can interchange these rows, row 2 and row 1 interchanged. So it will be 1 2 3 2 3 0 minus 1 and then 4. And now the row operation we can apply. So minus 3 times row 1 plus row 2, that will be row 2. So it will be 1 2 3 2, and then it will be 0. So minus 3 times 2 minus 6, and minus 9 minus 1 minus 10, and then it will be minus 6 plus 4 is minus 2. So this is the row echelon form. What we can do over here is 1 2 3 2, and then it will be we can divide it by 1 also. Okay, so what I will get is 1 2 3 2 and 0, and then divide this row by minus 6, so it will be 1, and then it will be 10 by 6 is 5 by 3, and it will be then 2 by 6 it will be 1 by 3. So now in this case what we can see over here is that this system has a solution. So in this case we can see that we have actually many solutions possible. So for example, in this case the first equation will be x1 plus 2x2 plus 2x plus 3x3 is equal to 2, and then the next second equation will be x2 plus 5 by 3 x3 is equal to 1 by 3. So we need to take the x3 as a free variable, and then we can find many different solutions of in this case. So in this case, since the solution is there, this solution this equation has a solution. So therefore, although there are infinitely many solutions, so therefore we will see that V is in the range of V is in the range of this transformation. Okay, so because it has a solution.